Hello and welcome, Denver ISSA members. And if you're not a member, go sign up. There's go to International's site and you can sign up and select our Denver chapter. So today is going to be our virtual event. It's the last one for June. If you notice on our YouTube channel, we've got a little slight change to it in the URL. We'll post that on our website. We've been able to finally permanentize something. It's not this long, weird character strings. We are looking at July and August to host some more virtual events, probably not the quantity you've seen recently in May and June. And we've been checking with venues recently to find out if we could do an in-person meeting to make this more personalized. But most of the venues are like, they're still trying to figure out how to get their office folks into their offices, and they're definitely not allowing third-party visitors in mass to attend these events. So we're going to be on hold for in-person meetings probably throughout the rest of the summer. So just be on the lookout and keep an eye on our website, and we'll provide you guys with updates. Today we have an awesome presentation by two great speakers. It's going to be Blameless, Retrospectives, and Development. So DJ is a DevOps pioneer. He's worked in streamlined development pipelines and practices for Fortune 500 organizations and focused on the culture. He's right now a master of security of automation at Rally Health. Our other speaker that will be here is going to be Aaron Reinhardt. He's expanding the possibilities of chaos engineering. I love that. And applications to other safety critical portions of IT domains, notably in cybersecurity. So with that, I'm going to turn it over to our two speakers. If you have any questions, reach out to our Slack channel and events and just post them there, and I'll try to ask these guys those questions. Thank you guys for attending and hope you enjoy the event.
I can't hear him.
Oh, there we go.
There we go.
Live streams. Well, hey, first off, thanks very much, Aaron, for letting me know that I'm running without sound. Thank you very much to ISSA for having us here today to talk about Blameless Retrospectives and DevSecOps at Global Healthcare Giants. Thanks, Scott, for that great introduction as well. So Aaron and I met, I guess it was about 4 years ago, and we were sharing similar roles at two different healthcare organizations. One of us was at United Health, and one of us was at Aetna. And we realized that after we had left both organizations, that a lot of the stories that we shared were very similar stories. And so we wanted to get together and put a presentation together talking about the lessons learned, almost in a retrospective style format, where we go in, find out what went well, what we could have changed, what our lessons learned were, and then we end up with a couple of funny predictions about DevSecOps and where it's going to go in the next 5 to 10 years. So Aaron, why don't you introduce yourself? Next slide.
All right. A little bit about me. I looked at this wanted dead or alive, alive preferably. No, I currently live in Washington, D.C. I am the CTO and co-founder of a company called Verica. At Verica, we are the creators of chaos engineering. My co-founder created chaos engineering at Netflix. I am most notably known for creating the application of chaos engineering to cybersecurity. I wrote the security chapter in the O'Reilly Animal book on that. I'm also finishing the O'Reilly book on security chaos engineering that comes out later this summer. I have a background in the Department of Defense, actually NASA reliability engineering. So it's it's not that far of a stretch to imagine how I got into resilience engineering. And like DJ said, this presentation covers my time as the chief security architect at United Health Group. While at that company, I helped kick off and lead the DevOps transformation, as well as we made open source a thing with Chaos Slinger, which was the tool we wrote that applied chaos engineering to cybersecurity. DJ? Oh, can't hear you again.
There we go. Yeah, I'm DJ Schleen, and I'm hopefully wanted more alive than dead. I live in Golden, Colorado, so on a green mountain about 6,200 feet above sea level. And I come from a background of software engineering. I've been developing software for upwards of, 30 years, and have participated in roles ranging from application lifecycle management, engineering, web design, web development. And I've always been a hacker. I've always been that tinkerer who rips apart machines and starts looking at how does this information go across a phone line, and how do we communicate, and how can I exploit it? And I didn't know it was an actual career in security until about 10 years ago, and I formed a penetration testing and security company called Trophy Security, based out of Lafayette. And then I went to Aetna and focused on DevSecOps architectures, automation. Started a little startup downtown called iTriage, and ended up coming into the Aetna organization, where I spent about 5 years doing enterprise software architecture, security architecture with our application security group. So in that time, did a lot of automation, a lot of working with development and engineering teams to try to get security as a part of what we do as a application lifecycle, and really address the security concerns that come out of that. We have a lot of different security organizations in any organization, third-party risk governance, GRC, and I focused as almost an intermediary between getting the information to those developers from those risk programs and compliance programs, but really having it in a language that people could understand. I left healthcare for about a year. Worked at Sonatype as a DevSecOps evangelist, where I traveled the world speaking about DevSecOps process and security engineering. And then I'm back in the healthcare industry at Rally Health, which is a part of Optum and the United Health Group. So
come full circle.
Yeah, right back where Aaron left. So we have a lot of experience in the healthcare industry and with security. So Aaron, why don't you start with pain and why we have DevSecOps, what the culture is behind it?
Well, I guess in terms of pain, the story at United Health Group, at least my story, began with listening and understanding the pain that software engineers were having in trying to build and deliver software faster to our customers. And I was if the largest section of my career, I was a software engineer over a decade, and I was able to really listen and understand and have empathy for what they were trying to do. And it really did take some strong listening skills, given a lot of the things that they were telling me they were doing, I probably shouldn't have been doing, but they're all doing it in the purposes of trying to do their job and do what's being asked of the company, deliver customer value quicker. And I guess that's where I come from in terms of pain.
Yeah, and myself, the pain was starting off with adding security controls when really nothing existed. If we look at the history of DevOps being 10 years old as of October last year, 10 years since Patrick Dubois came out and used the term in Ghent, Belgium, back in, 1999 or no? 2009. Gosh, time flies. DevSecOps really is a conversation that's only been about 6 years old. And when we started doing or implementing security controls, a lot of the pain was that there was a culture of distrust with engineering and security. And that was a big hurdle to overcome, because traditionally security has been the culture of no, where a developer says, can I use Go? No. Can I use Java? No, we don't know what that is. And a lot of that stems from security organizations not necessarily being the most technical of individuals or technical of teams. And that's been changing, I believe, over the past 6 years, where there's more security focus from industry perspective, from vulnerabilities that have been released. We've had to get ahead of our security and our vulnerability inside of the application. So a lot of the pain was cultural pain. A lot of the pain was just tool sets that just weren't available. If we start looking at how DevSecOps or DevOps tools today are, there's a plethora of CI/CD tools now. There's automated pipelines. We have GitHub Actions. Of course, there's Jenkins. And 10 years ago, what do we have? Like Cruise Control, Visual Studio Build. And so there was very limited selection in the tool sets that we could use. So dealing with that, when I went to iTriage, we had our own orchestration engine to manage containers in production. We had to build it ourselves using Mesos and Marathon. We wrapped a CLI around it and really implemented our SDLC in code because there's nothing available to do it. Fast forward to today, and we're still starting to see, well, we're seeing in DevOps these tools becoming widely commercially available, but we're at the situation where security tools haven't caught up yet. And that's a huge pain for developers, where we're trying to jam in, let's say, a static analysis tool, and it takes 30 hours for a scan to complete. That's not operating at the speed and the velocity that we need in today's day and age to react to business requirements and apply security to that. So there are tools that are starting to come together and that are starting to be available now that really can help secure things faster. And a lot of the pain that we felt in the past 5-6 years, and we shared at multiple organizations, have started to come full circle.
There are lots of, just case in point, there are several techniques. If you ever go to a software engineering conference, you'll see things like circuit breaker patterns. You'll see things like auto canaries and feature flags. Whereas, like, you ask your average security professional, they may not even be aware of that. These are becoming old techniques in software engineering. Whereas, we're just not keeping up. Is kind of what DJ's saying.
And that depends too on what organization you're part of. Some of these organizations that are 150 years old that got their first mainframe in 1950 or just got to agile. Not pointing any fingers at the healthcare industry, but feature flags is just this concept that nobody knows of. And it's like, we'd love to implement it, but we don't have the cycles. And I think that's where a lot of folks are from the pain perspective, is they'd love to implement all these things, but they don't have the ability to do them and fit them into their processes. So empathy is part of that. As I mentioned, the cultural conflict that existed between security and engineers, we really need to flip that on its head. And I have a story that I've told about. In Hartford, I had a meeting with a engineering team lead and one of his architects, and we started talking about Kubernetes and configuring orchestration engines using Helm and Helm charts, and basically getting workloads into AWS and Kubernetes. And they asked what team I was part of, and I said software security, and their jaws just dropped. They're like, "How are you speaking the same language that we do?" And it came back to, in 2017, the whole software engineering team basically spent most of the year trying to learn as much about DevOps, DevSecOps, and the tooling that we could implement so we could have these relevant conversations with those engineering teams, and we'd be on the same page. And what that did was give us that cultural collateral, or that cultural respect, street cred, for lack of a better term, with the engineers, so we could start communicating with them on an even playing field. And that kind of empathy, where we're talking the same language from a security perspective, we understand what the software issues are, the complexities of engineering, and then applying those security controls in a partnership. That's where we have to start. We say culture, tools, or culture, technique, and tools. The three things of DevSecOps and DevOps. Culture is always the first. We have to start with culture.
And I think a key part of empathy is because I always love to say empathy is a two-way road. Like, and what I mean by that is, like, I was a software engineer most of my career. So, like, as a builder, as somebody who's been asked to build things that have never existed before, I'm building something that no one else has succeeded in building before. It kind of like, I feel like the process in being a builder, being a software engineer, is like, it's kind of like, you try a bunch of things. That didn't work. That didn't work. That didn't work. Oh, hey, that kind of works. It's kind of this process of iteratively kind of making things work. And it's like, it's understanding kind of the crux of what a software engineer is trying to do. and the challenge that they're presented with also helps you understand how you can help them and how they may see success in terms of working with you. And that was a key component. At the time when we started the DevOps transformation, it was my ability to listen, but also the faculty to understand where they were coming from. Was very key. So,
for those out there who are watching and are in the Slack channel, I'd love to know how security in your organizations is really taken, or how they look, or how security is regarded by engineers. I think that would be a great discussion I'd like to see, and hopefully that can form some questions that we can address later on. It definitely is a challenge. The idea that security for using traditional tools can build out like 1,000 JIRA tickets and throw them to an organization and say, address these in 2 weeks, because our vulnerability SLAs are there. That's a dictatorship. It's not a democratic way of looking at things. And the first thing you're going to get is angst. You're going to get the project managers or the team leads reaching out to you and saying, hey, I can't do this in the next 2 weeks. I can't put it in my sprint. The business backlog is going to be affected by this. So we have to really think about different ways to turn that upside down. Look at techniques where we can integrate with pull requests or something like that for the engineer, where we don't even create a JIRA ticket. It's just something they do for quality of their product, or have a no-close ticket or something like that. Have a JIRA pull request that says, we're fixing this vulnerability, it's binary compatible, let's throw this in. So, thinking about things from an engineering point of view. And so our journey, sorry about that.
No, I was just going to say, it always surprises me how small, or how how small, or even whether it exists or not, software security organizations are in terms of modern businesses. It just doesn't make a whole lot of sense. I mean, like, most modern businesses are tech companies that deliver X, right? And your products and services are doing that via software, right? That's where the value is. But there's always so few software security people in it. That's got to change. And that was where I began in the journey. I think DJ had a similar story at ISSA, is that even at organizations at the time, there were pockets, but there was not really a concerted effort around software security.
Yeah, that's the same at ISSA, where we had a really good program. It was world class how Jim Routh set it up. Gave us the ability to really make a difference all across the organization. And then when we merged with CVS, everything sort of continued. We had that culture of collaboration, which was great. That was set up by Jim. One of the sort of tenets that we looked at was, if we had a skeleton crew of application security, we became innovative. And we looked at automation, we looked at different techniques, and we really thought outside of the box. And that was part of our success, because we needed to. It was a necessity. We had so many different programs we had to implement, and we knew that the journey was going to be long, but we thought about it from an innovative way and really leveraged the technology. And that's where some of these lessons learned that we're going to be talking about next comes from. So I love these love letters from the Old West. A lot of this, again, started when I was part of a small startup here in Denver, iTriage. And when I joined the team, I was brought on to be a mobile developer, actually. It was me getting off the road from a security organization perspective. I had been doing a lot of red team and avoiding getting arrested for breaking into buildings on pen tests. But, so with the birth of my third child, I got to get off the road. And so I went back into practitioner mode with iTriage. But I was brought on as mobile lead. And the first thing that I needed to do was figure out how we could get static analysis into that mobile build cycle, and rapidly address some of these security issues, not just in mobile, but in our web services and our applications as well. So
That was really when DevSecOps for me started about 6 years ago, was getting static analysis hooked up into an automation pipeline for mobile app development. Objective-C was supported at the time. There was a move by Apple to support Swift, and the tools didn't support that. So that was an instant, no, you can't use Swift. But there were open source software scanners available that did check the coding standards, linting, that kind of thing with Swift. But we were preparing for that as we started going down that journey. The integration was pretty challenging because we had Jenkins kick off a build. The build would go and it would, for iOS, would go to Xcode server. Xcode server would build the binary. If that succeeded and the static analysis was successful, we had 2 manual pull request reviewers. All 3 were reviewed successfully. Then the code would be integrated into the pipeline. We'd automatically generate a test flight or hockey app build and start distributing it via the Apple beta program. And then the same thing it was easier with Android because we could just use Jenkins to do that. We didn't have to shell out or do any finagling with an Xcode server for that. But when we started getting the data out, we realized that a lot of this tied back to different organizational units. So our governance and risk, compliance, third-party risk, identity access management, and a lot of the software vulnerabilities, if they were exploited, that information would automatically or eventually go to a SOC or something for incident response. So we started having this feeling that DevSecOps was more than just application development. It had stakeholders in multiple business units. And when we started this journey, it was a difficult or interesting conversation because we were introducing concepts that nobody had ever heard of before. And it wasn't even a thought that application development or application security would be such a big part of the programs that we'd have in place to reduce our risk from a product perspective. We're still dealing with organizations that traditionally had no reliance on mobile apps, or it was just a website, or even before that, it was brochures and call centers, really. So getting into the application space, was fairly new, and then transitioning that into applications have a lot of vulnerabilities we have to address because once they're out in the mobile world, they're out in the mobile world and we have no direct control over them. So we had to look at different controls for putting those in. Aaron?
I would say that, so a little bit about the United Health Group journey that I was a part of was, it was a very grassroots sort of bottom-up effort, if you will. As the chief security architect of the company, I was always getting involved in newer technologies, trying to navigate how do we secure them, how do we figure it out, how do we make sure they're compliant with regulatory, guidelines and whatnot. And so I was involved with obviously several product and application teams, and and I think it was part of Docker and OpenShift, those efforts that I started running into some engineers that felt comfortable with sharing some of these problems with me. And they started explaining to me about this thing called DevOps, and what they were trying to do is they were trying to, no matter how fast that they could ship and deliver software, security wasn't in alignment with what they were trying to achieve, and it was blocking them every time they were trying to accelerate faster. So I got together with, it was an unfunded effort. Almost every transformational effort I think I've ever been involved in several companies has always been unfunded. It's just good people trying to do the right thing and trying to do great work, right? And so we got together, about 60 folks, ranging from VPs, VP is pretty high level audit, all the way down to software engineers and security engineers. We got together. We came up with 6 different problem sets that we felt that were really impacting our ability to deliver software. Everything from security hardening and configuration validation to our dynamic application security testing. At the time, we were in order to get a scan done, of your runtime scans, you had to wait until the end of your build. You had to go fill out a form on SharePoint. It had to go into a queue. It went into a queue, and you whenever you came up, you got scanned. And then you have the lovely time of mitigating all those vulnerabilities, which could take 3 days or 3 months, and that just screws up timelines, hurts the company, and it's not a great way to be doing business. So I'm going to talk about the different efforts throughout the rest of the presentation, but there's a number of things here that we did that didn't work, that turned out to be complete failures, but those failures were great, though. That's where a lot of future success came from. Because we learned what didn't work. We learned what we could, where the path to improvement was. But we also did get some early successes with like the Gauntlet Rugged Attack Framework that helped us move our scanning left in the pipeline. And also our security baseline configuration validation with Chef's Inspect. So we'll talk more about that in the coming slides.
So there were a lot of good parts, a lot of things that came out, and we'll discuss in subsequent slides, as Aaron said, some of the bad parts that we had. Just a quick note on bad parts. The idea is that with DevOps, DevSecOps, you fail fast, fail often, right? And if you don't fail, then you're not saying something, because there's starts, there's stops. It's ultimate that some of the programs or some of the things that you're going to be implementing are going to fall flat. But turning that around,
it's part of being human.
Yeah, exactly. It's like if you're teaching your child to walk and they fall, you're not going to ignore it. You're going to pick them up and say, keep going, right? Run until tackled. So, some of the good parts that came out of the programs that we started implementing, and, we ended up taking all of this from the startup into the walled garden and the larger organization, but we definitely reduced the overall vulnerabilities in our code base. And that's from static analysis, from open source software analysis, container security analysis. Everything started trending down. And we did that in a few different ways. We set up, obviously, from what I said in previous slides, our static analysis program. So we're looking at KPIs that we set up. Defect density was one of them. And defect density has some problems we'll get into, but defect density was looking at the number of vulnerabilities in 10,000 lines of code. And we would use a threshold of 1. And if anything was above 1, that was, we've got to parachute into this as an AppSec team and see what's going on. And if it's under 1, that means everything was in control, and we could focus on the applications that were in the highest risk. If an organization business unit, which happened, had a defect density of 53, there was either a lot of false positives, we were scanning the wrong things. So we started getting these ideas of where we could look at managing our application risk. Then we also had a lot of success with the educational programs that we offered. We had you can call it a champion or an advocate or a Maven program with different belts: yellow belt, black belt, brown belt. And they're based on security training that our advocates, or really anybody in the organization, could complete. We had the white belt, was just standard security, application security, remediation, OWASP top 10, that kind of thing. And then we had additional yellow belt and blue belts that would build on that base knowledge and look at things such as how do we specifically address these OWASP top 10 or other vulnerabilities in our language specific code. So if you're an Android developer, we're not going to give you iOS training at that point. So you're going to start specializing in the technologies that you're using. We also had one of our directors created a attack and educate form. And it was meant to not only educate these security champions that we had, it was to get them involved. It was to have information on some of the latest exploits and vulnerabilities, but it was also to show them how to exploit something. Because if you get your advocates or some of your engineers to get a shell by exploiting a vulnerability, they feel like a hacker, and then they get it. They're like, oh my gosh, that was that easy to infiltrate this software and this ecosystem and this infrastructure based on an exploit. And it starts helping solidify the fact that application security is something that everybody should address and everybody should look at addressing in various techniques. So we also coded our application automation, and that improved the efficiency. And again, we had some stops, we had some starts with that. Starting to look at thresholds where we can't check in any additional vulnerabilities. And then if vulnerabilities are remediated in an application, taking that threshold down so that you're not introducing any more vulnerabilities, and you start trending the application down to defect 0. And then because we started oiling that security and development engineering machine, people could really focus on addressing these 0 days faster. We got to the point where we knew what applications in what organizational unit used a specific library. So think about like Heartbleed, libSSL. We knew every single Docker image that was set up that had that in it. And had we known that when Heartbleed actually happened, it would have been a lot easier. So, the good parts is we learned from our failures, from enterprise Excel gathering information to now automated systems.
Software dependencies, in my opinion, is still something that it's just table stakes, right? I mean, you got to take care of that. The supply chain is so important and so misunderstood, or not widely understood how it should be.
It's the iceberg, right? You see the tip of the security issue, but dependencies of dependencies of dependencies is that iceberg underneath the water.
Definitely. So I'd say some of the things that worked at United were, at the time, like I said, we had a very human-driven, manually driven scanning process, which really was difficult. We tried to actually automate it via API because we found out the tool had an API. We hooked it into Jenkins, we kicked off the scans, and I think within a couple days it broke the platform because the platform couldn't take that many requests. It just literally brought the servers to a screaming halt. And so that was one of the failures, but one of the successes that came out of it is that at the time I had seen some YouTube videos from, I think, Jason Chan at Netflix talking about a tool called Gauntlet, the rugged attack framework. And I reached out to Jason, like everyone does in Silicon Valley, over Twitter. And I talked to Jason, and Jason hooked me up with a guy named James Wickett. James Wickett is one of the first people to create the concept of what we now call DevSecOps. He wrote the first ever pipeline-driven tool called Gauntlet. It was him, Karthik Gaikwad, and Ernest Muller. And what the tool did was it moved dynamic application security. You're able to hook in things like Arachne, SSLIs into your pipeline. And if we weren't able to fix that scanning process at the company, we could at least get the scanning results to the engineering teams faster. And what we did, we actually did side-by-side comparisons with, it may have been formerly an HP tool, a dynamic tool with the open source Arachne. We got almost exactly the same results. But like what it was able to do is able to accelerate delivery and expectations and timelines for our dev teams because they could predict the amount, like they already kind of knew the vulnerabilities that were there and what they could address, and they addressed them as they were building out the software. They didn't have to wait till the end to find out they have 3 months more work. And that's just a shitty way of working. That's just not fair to have to be put into that. Another thing that was really valuable was we were able to drive down delivery times of our highly regulated. At this time, when I was at United, they had, I think they supported all the federal government's healthcare. And there's a lot of highly regulated workloads, and there were state exchanges and healthcare exchanges, and we had to, harden a lot of servers and things, and we had to verify that they were hardened. And we were able to get a open source software called Inspect that was originally based on Chef's server spec. We were able to write these configuration validation kind of code pieces and be able to validate that servers were hardened through the pipeline, right? So it wasn't a separate tool, a separate thing that had to run, a separate process, separate team. It would just kind of do it, and it shipped and said, hey, thumbs up, right? That drove down like 3 months of delivery time per team, per project. And another thing that it was sort of somewhat of a separate effort than the DevOps transformation pieces, but part of the transformation led to this follow-on project where we had everyone in security. Luckily, I had great management at the time. They supported my crazy ideas. I wanted everyone in all of the 1,000 people at United Health Group that did security, I wanted them to learn Python. Didn't matter what you did at the company, whether it's compliance or you're an engineer or you're a network engineer, you had to learn the code. And what was really valuable is that people started realizing, oh crap, it takes 4 days to get Python installed on or updated from Python 2 to 3 on my machine, or like the App Store, I had to fill out an exclusion or exception to get it installed. And people started realizing when you eat your own dog food, you kind of started realizing that pain, and then and as a human, you have that desire to want to help.
Okay, so let's start getting into our what we could have done differently. And Aaron, did you want to start off with that?
So can we have a do-over? Yeah. Well, if there was a do-over, hindsight's 2020, right? I mean, there's lots of things you wish you would have done to that would have maybe made things better, but in this case, I think that bottom up was really the movement. It really genuinely felt like a movement. People just doing the right thing and helping each other and across domains, and people that normally would never talk to each other were working together. And they're not getting paid for it. This was off the side of people's desks. But we did reach a point where the bottom up could only go so far. There was a needed for top down sort of support when it came to further funding. There was a point where we actually needed funding for things, and that would have been more helpful had we engaged and built those relationships more proactively. I think we should have focused more on the flagship company products at the beginning. I think had we made a bigger dent there, the transformation would have been more impactful and it would have spread quicker. Any transformation I've ever been a part of or ever even heard of, it's very difficult you have a difficult time in transforming the company if you don't start with the company's core products. Because you set a tone, you set an example, you prove what's possible, you show the value, people see it, and everybody looks to that team. And often it's actually one of the better teams to start with because usually they're well-funded, usually the best engineers. It's always a great place to start. I wish we had done more work there. I think I spent more time helping the software engineering teams instead of really educating my security counterparts. I think I should have spent more time in doing that, as I think that would have, because a lot of them had the ability to help, and they probably would have had I engaged them earlier and sort of changed their mindsets. But those are my do-overs. What about yours, DJ?
Yeah, dag nabbit. Looking back at this, like from a retrospective perspective, we started off with static analysis and security testing, so SAST, and that program, again, it's meant to look at the code that your developers write and look for security vulnerabilities in that. One of the problems with that is we should have really focused on open source software management first. Sonatype you come out with a bunch of surveys, state of the software supply chain, DevSecOps community survey. And from this, data was found that says, anywhere from 3% to 15% of any application is written by your own team. So the inverse of that is saying 85 to 97% of software developed by your organization isn't developed by your organization. And that's where a lot of these vulnerabilities tend to happen. We discussed a bit of the software supply chain earlier in this talk, and that is one of the biggest problems with software security today, because we don't know what kind of components our developers are pulling in. There's no centralization of this is the version. There's no SBOMs or software bill of materials that come out of that. And had we addressed that first, our static analysis would have run faster. So, we looked at implementing and integrating these tools first. With open source software scanning, it's milliseconds, sub-minute to get the information out of that and the vulnerabilities in a pipeline. With static analysis, with the traditional tools that are out there, we'd be looking at potentially 5 minutes for a microservice to 72 hours for 4 million lines of code if it's a brownfield app. So looking at that, I wrote a chapter in a book called Epic Failures of DevSecOps that talked about the static analysis program and how developers yanked it out because it was just blocking builds. They couldn't get a hold of the security team. So, we had a lot of problems just integrating this rather than really thinking through. And we started with that tool rather than the relationships with the engineers and saying, okay, when we put this in here, let's look at false positives. Let's burn these down. Let's look at things in a passive mode, right, before we start blocking things. And the nice thing is I have a do-over opportunity at Rally Health now where I'm in charge of the application security development or application security integration team. And my approach to what I want this team to do is look at a broad swath of these are all of our applications, either public, private, open source, not open source. If it's a repository, it's scanned. Looking at those, looking at the biggest risk applications and seeing what team is involved in that, and then parachute in, or not even parachute in, but partner with that team. Look at the vulnerabilities and see, is it a false positive? Are we scanning the right things? Like, are we scanning a bin directory with static analysis when an open source software tool does it faster? How can we optimize these things? And so that's my approach now, is broad strokes and then pointed interaction and partnership. And I think that will help the program succeed more because, again, it's going to foster the relationship and the culture and gain the trust of people to actually understand that security vulnerabilities are just bugs or just a work item. It's something you have to do, right?
You made me think of something I used to say when I was at United Health Group, is that with an earlier comment you had, is that modern software is not really built, it's assembled, right? It's assembled from many different things. I just would add that comment.
Well, yeah, think about like an automobile manufacturer, right? That's what DevOps really is. It's based on these lean manufacturing principles. Edwards Deming, Goldratt, all of these different influences that we had from car manufacturing in the 1970s, and the optimizations that really helped Toyota conquer the U.S. market from a manufacturing process. We're looking at the same way of software now. So we're not looking at software as just an app team developing, client server application. We're looking at it as a assembly line. And, you might have an assembly line that's putting a body or chassis together, an assembly line that's putting an engine together, and then another assembly line that's actually assembling all of this together. It's really important to plan out how your software is built and understand where you put the security in. And that's one of the lessons that we learned. Oops. Oh, so let's go to the Roadrunner slide. That was a big lesson for us. Security was trying to implement programs so fast, we didn't talk with the engineers, and we ended up running off a cliff. If you think of Roadrunner as engineers, we were Wile E. Coyote from a software security perspective. We're looking at all of these things we could do to secure a software, and then the developers just be like, well, what is this all about? What are you introducing? How does this affect the role that I have to play? So before you start running after a problem, definitely step back and try to solve it first. So yeah, the hold your horses, right? This is where we started failing builds right away rather than passively observing what we're doing. And when those environments get blocked, that's when you have that problem. And people would just pull those controls out again. If developers have something that's blocking and the business takes priority, they're going to pull it out. And it's very important then to have an exception process wrapped around this and a remediation plan process with your GRC tooling or your risk management groups, so that if there's a component, let's say, that's vulnerable or a vulnerability that's detected, and there's an SLA saying 2 weeks that has to be remediated, have an automatic exception created that can be logged by the security organization that has an SLA that's being addressed. And if you can't meet that SLA, work with the security organization and create a remediation plan. Say it's going to be in this sprint. And if the business accepts the risk, that's what we always point to from a security or application security perspective. Who owns the risk? And if the business is willing to accept the risk, that's where we really need to ensure we're getting alignment. Because if security accepts the risk, then there's really no action because we have no direct responsibility necessarily for producing the code that the engineers do.
Some things that went sort of just didn't really work out for us were, we, like I said before, when we tried to automate, it was actually the Fortified Security Center is what we're trying to go after. We tried to automate that via API. It totally crashed the servers. But that actually, because that failure caused, the security team to, think differently. I think they went out and they looked at cloud-based options to sort of help support this auto-scaling need for, the number of requests and compute, and that really helped, move things forward. Also, this failure with DAST and automating DAST really helped us open our eyes. Failure sometimes, is an indicator of like, hey, the current process is not working. Maybe we should be more creative, right? And we looked out to, there's this thing called ISSA, which is interactive application security testing, which it's more of like it's an agent-based sort of bytecode level instrumentation where it actually exercises and looks for security vulnerabilities of code firing in memory. And we were actually able to, because the way the self-service nature of how IS worked, it had a lot, and the fact that it's actual exercise code, it had a lot lower false positives, and we were able to save millions of dollars a month, in sort of human inefficiency by letting teams sort of self-police themselves and sort of run their own vulnerability. So that was really valuable, but it was the failure in automating the existing tool sets and process that drove to our awareness in that. Another thing that failed was we tried to implement secrets management, at the time, and I think in general, I think in the business in the industry, I think most security folks are confused between secrets management and privilege account management. They're not the same thing. The tool sets are not equivalent. They're different. They serve different use cases and purposes. There are some tool sets now that do both. But really, trying to have that discussion, it was very difficult to get that off the ground and make that successful at the time. Lastly, we tried to really bring in a container container image scanning open source tool called Claire. It was a great tool, but we just weren't able to get it to meet our needs. But it was a great effort. It drove awareness that we needed a solution in that space, and that we'd at least tried to come up with something to meet that need. And all of these, while they represent failures in our during the effort, manifested into a success in the long term.
Now, dynamic analysis, I doubt that you're doing that automated in the pipeline, right, Aaron? Because maybe kicking it off externally, but definitely not as an integrated part of staging, right? Where you're going from one step to another step, and that's a blocking action, right?
Exactly.
So that's something that we call out of band versus in band. So in band means it's going to be integrated in the pipeline. It could be a blocking step. For example, maybe it's a pull request looking at introduction of security vulnerabilities, and that's moving left, right? Moving left in DevOps, DevSecOps is all about getting this information to the developers as quickly as possible. But in situations where you have a long-running scan, like let's say that 4.3 million lines of code taking 72 hours, run it in parallel so that we still get the information and then correlate it back to the code build that is actually kicking that off. So Colorado territory here, it has nothing to do with what I'm talking about on this slide. It's basically a reference to, if you come to Colorado, you can golf in the morning, snowboard in the afternoon, and take a nice bike ride at night. And this is the lessons learned. People come here to find themselves, and then they either stay or they leave. And so that's one thing I love about Colorado. But the main thing is, if people aren't on board, nobody cares, right? If you don't have that partnership with the engineering team, you can talk about security automation till the cows come home, and nobody is going to implement it. And they have that idea that they're dealing with a traditional security organization, and they're not the most agreeable people, and it shouldn't really be surprising. So we got to change that from a lessons learned perspective. That's a cultural shift that we need to really shepherd and steer as a security application security perspective. Getting the right people involved in any DevSecOps transformation is extremely important. So, for example, I remember being part of a team meeting where all the leadership was involved. We had executive buy-ins. So that's that top-down approach that Aaron was talking about, for adoption. We're sitting at a table and we're talking about, how we're going to implement DevSecOps. And one thing I noticed was that the people who this is affecting, or our decisions were affecting, weren't even at the table. So we didn't have any developers, we didn't have any engineers, we didn't have any team leads. There were, upper management involved, but we're making decisions almost like a Conway's law type of scenario. And Aaron, you have a great example or a great definition for Conway's law. I'll let you say after. But we were getting to the point where we're suggesting what tool sets that people are using from a managerial level, what languages we would be writing in, and suggesting that. And that really takes away from the democracy of people who are actually building the software. Engineers are closer to our customers, and they know our software better than leadership, better than a security organization does. As a security AppSec, we have to change that, but we need to have conversations with the people our decisions are actually affecting. And I think that was something that I learned, that we need to as a do-over type of thing. And that's something that I'm really focusing on at Rally is, even before we start integrating security controls or even talking about them, understanding what people do and what the processes are is huge. Know or have a good idea where those risks are. As I said, paint that broad picture of where your organizational risks are from an application security perspective, and start focusing on them. So you might end up with a situation like you're looking at container images, and there's vulnerabilities that are very similar across all of the images. Well, maybe creating something like a golden image that everybody can utilize would take 50 to 90% of the vulnerabilities out of all your application, and it's a one fell swoop. So focus on things like that. Look at creating a, for lack of a better example, using Ubuntu 1804 Slim or something like that, Debian Slim as a base, creating a Rally Health base or UHG base or Verica base that will remove any of the cruft that's on that base image, and then building your application or your containers on top of that. That's going to help reduce the vulnerabilities. And then you can do some bug bashing or just even system hardening, where libbluetooth, we don't need that for a microservice. Have to remove it. Get it off of the radar so that if something comes across the wire, an amber or red alert saying there's this vulnerability in this library, instantly with the software bill of materials, and from your base images that you don't have to worry about it. So you can just head home on the weekend and snowboard. Or golf or mountain bike, and look before you automate again. And then, I believe that it's the human factor that of not being in control that inhibits automation. And it's not that we can automate everything, because then we can get into a situation Aaron will talk about where there's some caution in automation. But think about continuous integration, continuous delivery, and then continuous deployment. So there's two CDs in CI/CD. One is just sort of silent. And when you're integrating, have one trunk, everybody integrate into that. Software that's in Git or what your repository is should be always shippable. Delivering to a package, artifact repository, QA environment, that kind of thing, and then deployment, bringing it into a green environment or production environment. But when you look at continuous deployment, which is putting things into the production environment in an automated fashion, you're going to deal with things like separation of duties from a compliance perspective. Try to turn that conversation into separation of actors, where a system is an actor, a person is an actor, and then focus on the integration between the actors of your separation of duties. But the faster you deploy to production, what we're doing is we're really conditioning our software development organizations to think about quickly reacting to either business change or security change. So it's an actual security control. If you have iteration plan, something that's taking you 12 weeks, and then you have to do a hot fix to get a security library configured in there, you're disrupting your team's flow. But if you're continuously deploying into a production environment, through these automated or manual gates, and it's faster than it was before, then you can react to those vulnerabilities quicker. So in essence, DevSecOps and DevOps, well, it's ultimately going to create more secure software, but it's also going to lessen your lead time, or your mean time to remediate, or mean time to resolve security defects.
As far as lessons on my side,
Conway's Law first, Darren.
Conway's Law states that organizations are destined to design computer systems to reflect the way they communicate as an entity. And that's also when I talk about Conway's Law, it also plays into complexity in software, because there's two different areas of complexity in software. There's essential complexity, which is like the Conway's Law stuff. Basically, the way we operate as a business and function, the way we make money, finds its way into the way things we build. And that's the essential complexity that finds its way into software. There's accidental complexity that comes through the methodologies that we use and the ways in which we build software. And some people believe you can actually simplify complexity, but the larger, more accepted approach is that it's not about simplifying, it's about navigating complexity. And I guess that is also one of my lessons learned is it's not about trying to reduce complexity, because really all you're really doing is moving it around. You're not really reducing complexity. It's really about learning to navigate it. And it's also, you navigate it by building a culture of continuous learning. And do not confuse continuous learning with continuous fixing. Those are not the same activities, and they're not the same cognitive processes either. It is about failing fast, but when we say fail small, fail fast, it's about first accepting that the fact humans need and crave failure in order to grow, but the things we build are no different, and it should be an accepted norm. My good friend Greg Cherney always used to love to tell me during the DevOps transformation, he still tells me today, he's like, Aaron, something built is better than just an idea, right? So building small prototypes and showing people, whether it be assembling some open source projects or putting together some sample code, showing maybe a non-engineer kind of what you could do, right? So, like, here's what we could do. That little thing you saw in the CLI just saved us 40 days in work, right? Like, if we implemented this everywhere, we could save millions of dollars for the company, drive more value. I would also say that DevOps is not a fad. It's the future. It's the new norm. I argue chaos engineering will be the same. It's trending along the same as DevOps is, as well as automation is important, but don't be distracted by it, because automation, there's a paper written in 1983 by Lisa and Bainbridge, called The Ironies of Automation. And it's important to read that because people love to tell me that, you reduce the amount of people through automation. That's never been true. And there are certain ironies and taxes that come with automation that you must be aware of. But automation still is a key part of acceleration. Just be mindful of what you're getting yourself into.
So some predictions and not necessarily snake oil, but Aaron and I were just over the past few years, we've been talking back and forth about like what's next? What's next in DevOps? What's next in DevSecOps? So, a grassroots beginning, potentially not more so like, what's going on here in witchcraft, right? Tools haven't caught up yet. It's just That is just period. So if it took 10 years for DevOps tools to really mature, think about the next 5 years. There's things such as call flow analysis that I think are going to play a big role in security going forward. So think about if you do have some vulnerabilities or a vulnerability in your code, you have an open source component that's vulnerable, is it even in the execution path of the application? If it's not, the risk is reduced. And it's also easy to identify and say, well, since we're not calling it, we could potentially remove it. So it's like dead code. It's this. It's not only a security hygiene, but it's just a code hygiene, because the less code you have, the easier it is to maintain. And that comes back to complex systems are unmaintainable or more difficult to maintain. So current security tooling just really sucks. There's a couple of things that are great: open source software, container security analysis. Always look for things that are fast, and things are getting faster. A lot of organizations that do call flow analysis and security scanning, perform static analysis. They perform governance like license scanning. So you're looking for GPL, AGPL licenses that pretty much instantly open source your proprietary code if you want to comply with the licenses. It look for open source vulnerabilities, and these things usually are 40 times faster than any static analysis and security tool that's out there today. And these things are coming, so keep an eye out for those things. We're going to see more innovation in the detection, and that's part of it. And then you got to look at like tighter feedback loops for security issues. So DevOps, DevSecOps is again, it's failing fast, shifting information left, but also the feedback loops of how things are performing. So vulnerable code, finding out and getting it into the developer's IDE or closer to the developer, saying, this vulnerable code is being passed through 1,000 times a day by clients worldwide. Having that combined with the vulnerability severity and say, well, we have a low vulnerability function that's being accessed thousands of times. Is that something we want to address? So getting those tighter feedback loops in place. And then, I often contemplate in a philosophical idea, did we do the world a disservice by saying DevSecOps? And, that goes back to Aaron, you and I, and James Wickett, back in the rugged days. We're like, what is this DevSecOps witchcraft? And as well as John Willis, he asked me a long time ago, he's like, why do you call it DevSecOps? And also, why are you saying this at a DevOps conference? Like, are you insane? And, it was just basically there, I think, to call out the fact that security needs to be everyone's responsibility. That's part of the DevSecOps manifesto. Is that achievable? Absolutely. I think as a whole organization, we're going to have to start thinking more securely, especially if we're in healthcare regulated industry or we're dealing with people's privacy. We all have to be cognizant of it. But at the end of the day, application security, we're all engineers. We're all developers, engineers, and we're trying to build safer software sooner. So, my funny prediction is DevSecOps becomes known as just simply engineering.
That would be joyful. It really would. Is that it's some odd reason we still live in a world where people believe there's a system and it's security and they're separate things. It's either the system is secure or it's not, right? And it's just a part of the engineering. And security is one of many human constructs that are part of the engineering process, meaning that no system is high quality, resilient, reliable, or secure without a human creating that construct, right? And it's engineers that create things. So it's like, I just think it's important to see it all collectively. I agree as engineering. I believe the next generation of security professionals will be chosen from DevOps teams. I think there will be a generation, and it's kind of already starting, of security-focused SREs. I think SREs, when Google originally sought out, they sort of left security out of the playbook. They've come back and they've recently written a new O'Reilly book that has sort of includes security in building reliable systems. But I think it just makes so much sense to have SRE and security, or at least security part of the SRE playbook. I think security, if we're going to survive and continue to communicate in terms of business value, security organizations, professionals need to know where they stand in terms of the value chain for a company. Like what part of the delivery of value at the company do you contribute, right? What have you done to contribute to that product's improvement? Because when you can actually see yourself in the value chain, the company does well, you feel a feeling that you may have never felt before that, hey, I was a part of that. Hey, I did that, and that's valuable. I also think chaos engineering becomes a core discipline within DevSecOps. I may have been the beginning of it, but I'm seeing it sort of explode. And as part of writing the O'Reilly book, I have all these companies reaching out to me that are doing it now, and they are incorporating it mostly as a part of either SRE program or a DevSecOps type of approach. And lastly, I think that it was my personal ambition to see compliance in DevSecOps just be a byproduct of good engineering, and that would be lovely to see.
So that brings us to the end of our presentation. We got one more slide that we'll shift to. I would love to invite anybody who is interested in DevSecOps, DevOps, and is looking for a position. I'm looking for a senior DevSecOps engineer at Rally Health. Reach out to me. I would love to talk with you. It's a remote position, or if you're in DC, it's you can be on site as well. We do have offices in Denver as well. So I'd love to have you apply or reach out to me, and I can send you the links to that. You don't necessarily have to know a lot about security, but definitely about DevOps. And that goes back to Aaron's conversation that the next generation of DevSecOps or security engineers are going to come from the DevOps practice. But if you know how to code, you know security, and you're interested in joining a really cool program we're going to be world class from a software security perspective, let me know.
And I'm going to put one last plug. DJ and I are kind of Twitter addicts, so our Twitter handles are down below. I respond to all DMs, so feel free to reach out. Plus, if you'd like a free copy of this O'Reilly book, there's a link for the Cutley. You just go to Cutley/Verica book and get a chance to get the O'Reilly book. So,
cool. Hey, DJ and Aaron, this is Sky. I think your presentation is fantastic. I think, in fact, it's one that I'm going to have to rewatch. There's a lot of content and a lot of bullet points because I think you guys give a lot of kind of just great. You kind of sprinkle in developer tips. You keep it security focused, but I think there's some other ideas just in concepts there that you have in some of those fancy slides you guys have of the Old West for developer tips. I like it. I like that mixture of it, and those are really key things. So a couple of things, I didn't want to interrupt your slide. You guys were flowing. I didn't want to just kind of jump in and out. So a lot of times I think you're right in this generation of engineers and developers and security professionals that you're seeing that folks that are becoming cybersecurity specialists, and then you've got developers uprising and becoming developers. But the two, sometimes the organizations have different reporting structures. They have different people they work with. And then all of a sudden it's like, oh, you're developing this application over here. And these engineers from security, if they don't know Haskell, they don't know any Python, they don't know any of these DevOps terms, instantly the engineering team, the engineers, the programmers, we'll call them, instantly will be like, within 5 minutes, it's a tough world. But if they know that security professional practitioner doesn't really know how to speak their language and what things to look at, a lot of times the DevOps might write them off. Is that the new generation? Is we just have to wait for that event to happen? How do corporations bridge security professionals that know nothing about DevOps or development, and then DevOps guys that know less about security?
Well, I'll take that one to start with, Aaron. And this is something that has happened that I'm part of now, is have security and engineer fall under the same VP or CTO and a CISO for that matter. But I think we might see the CISO become more of the CIO in the future. But
I agree with that statement.
You agree with that?
Totally agree with that. I think the creation, I think the creation of the CISO role was kind of a mistake.
Yeah, it's an interesting role to be honest. But if we start looking at the reporting structure and making people accountable, both engineers and security, I think that's a start. But you know, if someone in AppSec, well, and that's the thing, form an AppSec group, because a lot of organizations will have that third-party risk governance and risk and compliance, and then they'll start engaging with the engineers, and it's just like speaking two different languages, right? It's like speaking English and French. You know, if you don't understand the other language, you're just not going to be able to communicate. So, you know, that's where the education and training comes into play. And that's where, you know, you need to have a specific application security group, even if it's a, you know, skeleton crew of people that know the development languages that your organization is developing in. So, you know, Rally, there's Scala, there's Python, there's Go, there's a bunch of different languages that are out there. You know, maybe it's the onus on the security organization to have people trained in, you know, like Aaron did with Python, because the flow control constructs are the same across languages. It's just syntactically a little different. But, you know, understanding like if, then, else, you know,
need, right? Yeah.
You know, variable assignment, things like that help them get past it. But again, a lot of AppSec is looking at the security vulnerabilities and then working with engineers to try to remediate them. And at that point, you're going to start understanding pretty quickly with the rudimentary, you know, languages that you might know what's going on with the flow of the app.
I think so. Like, I think I probably need to finish out my hot take, right? With the CISO role was kind of a mistake, and I don't mean it's entirely it was a mistake. You know, the internet loves opinionated people and opinions. So I used to love to, DJ knows this because he did a couple of these with me. We used to give talks to like these senior executive conferences for the Fortune 100, like, you know, the CIOs get together and they give talks and, you know, they round tables kind of thing. And somebody once asked me, I was on a panel, like, if I thought the creation of the CISO role was a mistake, and I agree with that. The reason is that we created a role. We didn't have accountability for security of companies, so we needed to create a role for someone to ensure that accountability. Right? We created a person and a role, and then as a byproduct of an organization. But none of those people can actually do anything to affect the security. Right? A lot of people in security, you're not actually changing to make it more secure. You're either pointing out you're running a tool and you're saying the tool said this is not secure. You know, or you're taking output from an engineer and you're translating that into, I think this is a low, medium, or high, and like it's we need to find more alignment back into engineering instead of continuing to take sort of a Y path, and I think that the more. So here's another controversial thing. I think all people in security must learn to code, and I believe if you're not actively going towards that path, 5 years from now, you're going to find yourself in a very precarious career path, because software has taken over the world. I mean, I don't know if you've seen the new OSI stack, but it's software, right? There's only 3 components you build with anymore: software, identity, and the network, right? And like, you know, I think the more you get into engineering, and I have actually found the highest paying careers out there are the engineering positions, believe it or not the management positions. So anyway, that's my opinion.
No,
that was a great comment on the. Oh, sorry. One other comment on the CISO role, and it's not that way today, because I work for probably one of the most brightest and technical just knowledge about every CISO. You sorry?
Dan Walsh is amazing.
Yeah, he's beyond exceptional in the role that he's doing, and I'm very privileged to work for him. You know, 5-6 years ago, or even a little bit before that, when the CISO role started becoming you know, heard of in the market. So you got the CSO, the CISO, CIO. There's a C of everything, right? But I always joked around, and Aaron knows this too. I said that, you know, CISOs are just senior security engineers or senior security folks that were just in the right place at the right time. And it's like, hey, you own this, right? Because if there's no security organization, the CEO owns the risk from any breach that occurs, right? So then it's you start getting these abstractions, and now the CISO owns it, but the CI, you know, there's all these different things.
They can't own it, right? They can't own it. They can't own the risk. The business must they shifted accountability to a person instead of taking the accountability they actually own. Anyway, yeah.
Well, and when we look at certifications, a lot of them are starting to come up. There's certain certifications like that I was looking at. They focus on a lot of risk. They focus on governance. They focus on risk calculations. There might be physical security, but some don't even have a word of app security in there. And that's where I think some of the certifications need to catch up. And I think some are, which are great. And so that's something I think, from a prediction perspective, I think we're going to start taking app security more seriously.
Yeah, and I think you mentioned a term in one of those certificates that comes up. You talked about secrets management versus privilege management. And I can tell you right now, from a practitioner standpoint, it's only at the privilege management, and that's where it ends. What's the secret? So for those viewers that are watching, explain a little bit more what secrets management.
DJ,
you want me to take that one first?
Oh,
I can comment a bit first. So, one of the things that we're working on now is a centralized area for developer secrets. So these are passwords to databases, they're API keys, credentials, that kind of thing. Because what we want to make sure of is, there's a pervasive problem with people checking in secrets into GitHub. Either even if it's public or private. Like, if it's private, well, you're still sharing that secret with your entire organization. What happens if you start offshoring work and those secrets are there and they have access to PHI? Well, instantly, you're in some deep compliance problems. So looking at a centralized place where you can have short-term secrets, right? So like, let's say you want to assume a role to do some administration in AWS or Amazon, Cloud, Google Cloud. You assume a role, the role has a limited lifespan of 15 minutes, you never see a credential, and then after that, it's expired. Or in your application, your application, you're getting tokens. And then secret management are also some of your private and public keys, so your certificates and that kind of thing. So, we heavily use Vault to do a lot of this. There's multiple products that do this. But if there ever is a breach, you hit a button and everything is revoked from a permissions perspective. And that's a very application specific problem. So Aaron, you want to probably add some to that and then maybe talk about PAM a little bit too.
Yeah, so Vault is really, Vault was really, from my opinion, my standpoint, well, this is I'm talking about HashiCorp's open source Vault, or even their commercial tool, but the open source secrets management tool Vault that HashiCorp released was the first ever purpose-built secrets management tool, right? So a lot of your privilege account management is more like domain admin kind of or software service accounts, network device accounts, things like they're more like, they're admins. They're it's not like administrative, like a key and a token kind of can serve as an identity, and there is confusing in the words we use around, but secrets are really pertaining to the software, right? And how software operates in terms of identity in keys, and if you're not using a secrets management tool, I guarantee you, so if you don't have one at the company you're at, you should start looking through, searching through code, because it's hard coded in the code, or it's in a text file somewhere, or it could be even worse. So if let's say your software engineers are being security minded, they could be vaulting their stuff in a bunch of different places. And if new engineers come in and don't know that or don't know how to access that, you can end up being locked out of your stuff. It could be, because things like I think JBoss has its own vaulting capability. Different kind of web servers have their own,
Kubernetes secrets.
Yeah, Kubernetes secrets management. I remember when I originally worked at Kubernetes secrets management, for at least in the OpenShift documentation. I was looking it up to kind of learn about it, and it said, please do not use this. Cause there was basically, I'm sure it's gotten better, but maybe not. But it's, when I looked it up, it's basically the way the operations work and how the accounts that access the actual secrets, at least at the time, the keys never actually got encrypted, right? So it's anyway.
If anybody out there gets a chance, and has access to get read-only access from a security perspective, or whatever SCM or source control management system you're using, check out all the code and do a recursive grep for the word password, case insensitive, and you will be surprised because
it could be scary.
Well, it's going to be scary because you're going to have hard-coded passwords. But the second part of it is people will comment out passwords. So they'll have, this is my development password, this is my production password. They'll comment them out. So like a static analysis tool won't pick them up because it ignores comments potentially. So there's intelligence systems, again, that'll go out and they'll look for that. Look for something like, OWASP has, SonarQube or something like that, right? And look for the open source version of that to start doing linting and look through the code and say, oh, wow, we got passwords here. Because that kind of hygiene will definitely help in the long
This is the stuff data breaches are made of, right? I mean, because let's say, for example, it's also good to check. GitHub.com has actually fixed this in a lot of their stuff. They didn't used to look for secrets in the code, but you could have people posting their code or copies of their code out on GitHub, right? And then I think it was Tesla. Was it Tesla? No, it wasn't Tesla. It was it was Tesla. Tesla got breached through keys being exposed on GitHub, I believe.
Yep. And think about in a regulated environment like healthcare or finance or, anything that's PCI compliant, SOC 2, NIST, whatever, government. Imagine putting an API key out there and then having your entire health history for every single person in your organization pulled because someone checked in one key into GitHub. Everything, no matter if it's public or private, right? You can easily flick a bit in a private repository and make it public. Or if you do a fork of a private repository, you can fork it into a public repository sometimes. And so it's definitely important, even if it's not production code, scan it and look for these things because you're one click away from it being a problem.
Yep. All right, so I got two things. We got 6 minutes, and I don't want to run over with you guys, but we'll talk about one, and another one I have a challenge for your Twitter accounts. So I'll give you the Twitter account challenge, which is maybe you could post something on you said you've written a book, but I also want you guys to post the books you've written and some books you would recommend, both on the development side to get into the security side, as well as security guys trying to learn development side. What would be your top 3 books or reading material that people could get further deep into understanding to where you guys are at? Obviously, you got one here, this free one, Chaos Engineering, which is kind of new for me. I was in the agile world. But this I was just reading up on it. But yeah, post on your Twitter account so people can follow up, reference back to this YouTube channel for sure if they want to know where those challengers are coming from.
Essentialism by Greg McEwen and Your Code as a Crime Scene. So you can start looking at digital forensics of your code. So definitely a heavy book, but Patrick Dubois recommended that I read that, and it's pretty interesting. But Essentialism, the relentless pursuit of less. So
okay,
it's think about lean and think about even being less than lean.
All right. So what do you think?
So obviously I'm going to self promote this book is only 2 months old. So the problem with chaos engineering and adoption is there's never been a body of knowledge. It's always been a bunch of blog articles and open source tools. We now have an official body of knowledge to pick it up. You will have a security chaos engineering O'Reilly book here at the end of the summer you can read. And just stay tuned to my Twitter, and I'll announce it in the summer when I'm actually done writing it. But also release it by Michael Nygaard. This is a great book for learning modern software and how to design and deploy production ready software, as well as another book that I'm going to throw out there is here's one that's not a book anymore. AutomateTheBoringStuff.com. You can learn Python in about 3 hours. That it was originally a book series for learning Python, but I think they just gave away the book. The author did online. So it's the fastest way to really learn Python. And remember, Python was originally written for children, so that's why it's so easy. It's easy to learn, but it's hard to master because of the extensibility of the modules. And the last book, this is really the last book, is The Field Guide to Investigating Human Error. by Sidney Dekker that will literally blow any security person's mind, because it talks about how the role of humans and human error, which we always love to blame everything on in security, but in terms of complex adaptive systems. Sidney Dekker has been studying airline accident investigations for over 30 years and pilot error, and everything in there, it makes security. And it will blow your mind as a read.
Those are great recommendations. That's awesome. So I don't know how we're gonna do this in 3 minutes, because I'm fascinated with a lot of your slides. But you guys mentioned, and how do you recommend for a security professional, going back to your slide about you're really assembling things rather than coding things from scratch. How do security professionals examine these third-party components that are bolted into the code? Because a lot of times when you start to uncover the coding, you're finding, oh, they're calling this up, they're using this from GitHub. What are your thoughts around that in terms of how do you get your hands around doing assessments of what these additional components that are being assembled into the code?
A couple of ways with that. If your code's in GitHub, there's something called Dependabot. OWASP has dependency check that you can run inside of like SonarQube. Commercial solutions are available: Sonatype, Sneak, White Source, Black Duck. There's a bunch of different tools that are out there. What you're going to want to look for is a few different features. One is, scanning and applying policies. So policy enforcement is huge, especially for your compliance. So you're looking at first all the components that are out there, what the vulnerabilities are there, what the risk score of it is. Like if it's a score 9, that's something you need to address with an SLA behind it. You can look at products to block any components that come into your infrastructure and say, you can't bring anything with CVSS 5 or higher, right? So you can start looking at passive modes around that. The biggest thing, though, is scanning for vulnerabilities and creating your software bill of materials. So a software bill of materials is going to have the name of a component. So like jQuery is going to have the version in use. It's going to have a vulnerability list, and it'll have, potentially, depending on the software you use, what version it's fixed in or the issue is remediated in. So that's going to give your developers a remediation path. But it's a really, really quick way to just really reduce the risk across the board from a software security perspective. And it's going to give your SOC or your incident response team the ability to know where these things are, rather than survey people and have them say, I don't think we use that. It's going to be concrete, irrefutable evidence that you have that.
Okay.
That is a comprehensive, holistic answer. I have nothing to add.
Oh, that's perfect. Well,
run it up the band first, though. Don't integrate it. Just get an idea of where things are first.
Agreed. Well, thank you guys very much. Again, this will be posted for who knows how long on our YouTube channel. We'll keep it so people can go back, examine those slides a little bit more and get some more watching this presentation. I appreciate guys presenting on ISSA. We thank you for having you guys here. Hopefully we can get you guys in person sometime next year if we can do an in-person conference. I think you guys have some really good content and a lot of great ideas, and just kind of bringing forth the maturity of what and defining what security DevOps are, which boils down to engineers. So thank you guys very much for your time.
Well, thanks for having us. We really appreciate it.
Thanks.
So, all right.